Simply put, Geoserver is an open source product which is developed in Java using enterprise Java architecture for the GeoNerds that can allow you to take your geospatial data, let's say shapefiles or spatial DBMS like PostGIS, and publish it to the web.
Welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the geospatial community. My guest on the show today is Simone Giannocchini, and he is the director and founder of Geosolutions. And today on the podcast, we're going to be talking about Geoserver. Just before we get started today, I want to say a big thank you to the open source Geospatial Foundation. You might know them as OSGeo. They have helped make this podcast episode possible. So thank you very much for that. I really appreciate your support. Hi, Simone. Welcome to the podcast. Today, we're going to be talking about Geoserver, which is a fantastic piece of technology. I have a little bit of experience with it, but I know that you know a lot more about it. I think before we get into the conversation around Geoserver, could you just perhaps introduce yourself to the audience and maybe explain how you got involved with geospatial?
Well, my name is Simone Giannocchini and I'm the director and founder at Geosolutions. I got involved in geospatial, it's like 70 years ago. I was working in a completely different environment and field. I actually come from university and doing real-time systems. And then I got this contract at the NATO Center in Italy where I started to explore GIS. It was supposed to be a 6 month contract, but I'm happy to say it's been now more than 17 years that I'm working with GIS.
Was that a difficult transition to make from working with these real-time systems to geospatial? Because I'm thinking there's a lot of crossovers there.
Well, yes and no. It's actually interesting. It was at the beginning of open source. I actually got interested in this position because I was working with completely different stuff and I started to work with MySQL, the embedded version at the time, and I started to play with open source. I saw that this position, they were actually looking for someone to help them with the transition from Esri to open source. So this helped me to explore PostGIS. I mean, we're talking about the early era, I mean, of open source for PostGIS, Geoserver, MapServer. I mean, Open Layers wasn't there. For people to remember, we were talking about Map Builder or building things yourself. So I got like 1.5 years to explore things with them and learn from the ground up. So it was, it was, let's say, a steep learning curve, but it was extremely interesting.
Yeah, I can imagine. And so you will have seen a lot of changes in GeoServer over time, and that's the topic of the conversation today. And I think we should start right at the bottom. What is GeoServer?
Simply put, Geoserver is an open source product which is developed in Java using enterprise Java architecture for the GeoNerds that can allow you to take your geospatial data, let's say shapefiles or spatial DBMS like PostGIS, and publish it to the web, both as nice looking maps or other type of services where you can directly access your data, also raster data like GeoTIFF through protocols that are standards from OGC and ISO, but also de facto standards like TMS and so on. So the idea is to be able to quickly serve your data on the web according to a certain number of well-known protocols.
What does it look like when I download it and install it? What's in the box to help make those things happen?
Well, that's a good question. Geoserver is a platform, if you want, but also a product. The product you download from the web is what the Geoserver team decided to be the product. So it's a selection of the most important, in our opinion at least, input plugins, so plugins that can read input format, as well as services, which means which protocols we believe are part of the standard product. We try to focus a lot on simplicity and usability, so allowing people to quickly go from I want to use Geoserver, so nice, I'm using Geoserver to publish a map. A number of formats are supported by default, like for example, GeoTIFF, PostGIS, shapefile, obviously. Some requires free and open source extension, also due to the licensing of the, let's say, part of the plugin itself, like Oracle. Right away, when you publish a shapefile in Geoserver, which you can do through a GUI, which is, let's say, decently nice looking to be an administration GUI, you can very quickly go from a shapefile to having a map to be published on the web, as well as the ability to make queries directly to the shapefile through specific OGC protocols like WFS.
Okay, so we're working with geospatial data, obviously, and we've got raster and we've got vector. You were talking about publishing a shapefile on the web there. I know that Geoserver supports Postgres, for example. I also know it supports MS SQL. Are there other kinds of databases? And I guess my follow-on question is that does it have to be in a database or can that be a flat file on my disk somewhere?
It can be a shapefile, it can be a geopackage. Most of our clients are in the enterprise arena, whatever that means, and they work with different types of databases. It's usually either, let's say, most of them, it's either PostgreSQL or Oracle, but it can be, for example, we have clients using SQL Server, as you say. They can use Mongo. We have clients using Elasticsearch. So the number of plugins that GeoServer makes available, hence the number of formats and input formats that it can serve, is actually pretty extensive. The usual use case, to be honest, for most of the clients, it's either shapefile or PostGIS and Oracle. Although I see that GeoPackage is actually getting some momentum also as a format for serving.
If I want to publish my raster data, my image data through Geoserver, what does that look like? Does Geoserver just say, just put them in this folder over here, or does it store it in some kind of Geoserver internal structure?
Well, your mileage may vary. The easiest thing is if you have a GeoTIFF, you can just point GeoServer at it and serve it. We usually recommend to pre-process it a little bit if it's big. The usual things you can do with GDAL or QGIS or even ArcGIS, overviews, tiling, and so on. So the baseline is very quick to do. If we have installations of GeoServer that are serving petabytes of raster data from, for example, Earth observation missions, or from drones and so on. Well, in that case, things obviously get a little bit more complicated. For example, we tend to use COG a lot lately. GeoServer doesn't have an internal format, which is somewhat proprietary or specific to GeoServer. It tends to use the data in the format you have. Although, as I said, we usually ask people to pre-process and optimize them a little bit.
When you say pre-processed, are you assuming that people do that in something else, maybe QGIS, or perhaps use GDAL for that? Can I do this through the Geoserver administrator interface?
Well, you can do it with GeoServer, but we usually don't do it in GeoServer because it's usually computational intensive and it's not something you want to do on the same servers where you are actually serving, for example, get map requests for mapping, because they would actually compete for the same resources. It would end up in bad performances. Usually, in large infrastructure, pre-processing is part of an ingestion chain, which is done separately from GeoServer. And most part of the time, GDAL utilities are involved one way or the other.
So I realize we're sort of moving quite quickly through the conversation here, but there's it might not be an extension anymore, but it used to be an extension. It was called Geo Web Cache. Is that not part of the pre-processing? If I want to build tiles, for example, should I be doing that, building my tiles with GDAL somewhere else and then moving them to the server and pointing GeoServer at them?
Well, again, it depends on the use case. For most of the use case we work with, it's close to impossible to generate a complete cache upfront. So let me take a step back here. GeoCache now ships by default with GeoServer, so it's integrated. And you can still use it standalone, but it's integrated. And as I was saying, most part of the time, we let GeoCache jump in when you ask for tiles and create the cache as needed without any seeding. Sometimes we do seed at least some levels. Let's say if you have a web application and you know that your application lands at certain zoom levels, it's a good, let's say, practice to cache at least at those levels. But on average, we tend not to cache in advance. The only cases where we do this is background maps, because you know they don't change frequently and you need them for a long time. So in that case, you can, as part of the, let's say, pre-processing, you can ask GeoCache itself to generate the cache for you. You can also, with the latest releases, you can also generate them offline in MB-Tiles or GeoPackage and put them behind GeoCache. I don't think it's yet released. It's something we developed for the German Space Agency, but that's doable as well.
Okay, so we've talked a little bit about the different kinds of data, these different kinds of data stores that we can use, what we might want to think about before we publish data through GeoServer. Maybe you could just walk us through what kind of services we can publish our data in using GeoServer.
Yes. Well, as I said, I actually touched some of these topics a little bit. We work, let's say, most of our clients who are in the enterprise arena, they work with, let's say, corporate databases, and this is usually either Oracle or PostgreSQL. Because we tend to use Geoserver in larger workflows. Think about a large city or a region or an organization that is producing and selling data. The Geoserver tend to sit on top of a database where one way or the other, it's actually the endpoint of a long data production pipeline, which can be automated, think about sensor, or which can be generated by humans. This happens a lot, for example, with water, river authorities, and so on. There is a lot of manual data production. So this is usually the number one thing for vector data. For raster data, it depends. I mentioned GeoTIFF, which is like the Swiss knife of raster data, especially with COG. But we do work a lot with NetCDF as well. We work with organizations that are more in the so-called METOC arena, meteorological or oceanographic, but also atmospheric, where they run models for forecasting. So they produce NetCDF. And the key in this arena is usually to get the data as quickly as possible to the web, because the importance of the data decreases quickly as the freshness of the data decreases, if you see my point. The older the data, the less relevant. So we work a lot also with these formats. These are, let's say, the most common formats for raster and vector data. In terms of services, well, everybody likes maps. Everybody wants to see maps. So the number one protocols are those, let's say, involved with map generation, WMS, Web Map Service, WMTS, Web Map Tile Service, and so on. But usually, as I said, being in the enterprise environment, people are not simply happy with maps. They want to do more. They want to drill down data. They want to be able to put them on a chart. They want to run some processes sometimes. So we do use a lot, for example, WFS, which is the Web Featured Service from OGC, which allows you to access vector data. It's like having a geospatially enabled SQL interface that you can call from the web and get back results in JSON or GML, which is a dialect of XML. We do work a lot with WPS, with web processing service, for extended functionalities, like, for example, the ability to compute statistics or compute aggregations on vector data and turn them into nice charts that you can see from, for example, our client's map store. We tend to work also quite a bit with WCS, which is the counterpart of WFS, but for data. It's the web coverage for raster data. It's the web coverage service. And it's used actually if you want to subset, crop, reproject, subsample or resample raster data and get back numbers rather than an image. Okay, so this is more or less what we do on average.
Just out of curiosity, how does the web coverage service, I think you described that brilliantly there, as the raster counterpart to WFS, so the web feature service, how does that differ from a cloud optimized Geoserver, for example? Because it seems to me anyway, on the face of it, they're solving the same problem.
Well, yes, if you want, and no at the same time, like everything. If you want to simplify a lot, the advent, if you want, or serverless architecture or server free, so there is a slight difference between serverless and server free. And COG is actually shifting some of the processing and, if we want, pre-processing in order to do analysis and visualization to the web. Because especially with COG, you can basically transfer quickly numbers from the GeoTIFF to the web and being able to do compelling visualization directly in the client. The distinction between what you can do server side with WCS and what you can do with COG is actually fading more and more. But let's put it this way: if you have one thing is having a GeoTIFF as big as it can be, another thing is accessing 20 petabyte mosaic seamlessly and being able to subset a portion without having to implement client-side the logic to mosaic, if you see my point. One thing that I've seen that could be interesting in the future, you can actually think about COG not really as a GeoTIFF, but as a WCS-like interface, and behind you could have everything. So it could be an output format for WCS, while you still have WCS in the backend doing all the magic. Okay, rather than having a single GeoTIFF and accessing through COG, it could be let's say a virtual GeoTIFF, and behind you could have a WCS that does everything.
Thanks very much for clarifying that for me. I really appreciate it. Another thing I haven't worked very much with is the web processing service. I see it's one of the services we can expose our data through via Geoserver. Would you mind just talking a little bit more about that, what it is and perhaps what it can do?
WPS is one of the most interesting services, if you want, from the OGC, but also at the same time is one of the least understood services. Because in the end, to a certain extent, is a black box. The WPS per se, it's actually a way to expose processing like routines, if you want, or existing services to the web and being able to call them in a standard way. So the magic is really done by the process itself that you expose. If you look at the examples, 90 until I used to do this joke, I mean, until a few years ago, everybody implemented a buffer, but I mean, in reality, you don't really need a WPS to do buffering for vector data. Okay. The usual example I give out of the reality, at least for us, is that sometimes standards are good, but they don't cover all the different needs, especially when you have to do a project. So WPS gives you a quick way to implement functionalities you might not be able to find them in the existing protocols. For example, in our WebJS client in MapStore, we use by default, a few WPS processes to do more advanced stuff like the aggregations of vector data for the charts, the ability to ask stupid things which we didn't find a way in WFS to, for example, ask for the unique value on an attribute on a certain dataset, etc., etc. But it can range up to more advanced stuff. I've seen in the OGC interoperability experiment people using WPS to expose machine learning and artificial intelligence stuff at the beginning, where there wasn't a clear way or a specific service for this. Now they're discussing more and more. Maybe they'll come up with specific services. So WPS, it's actually a black box that you can fill with things that you want to expose to the web in a relatively standard way.
Could we just stay with this for a little bit here? I just want to make sure that I've understood this. We can chain together these services. Now, I guess my next question is, are these predefined functions that exist within Geoserver today that we chain together? Or are they scripts that we write ourselves and then have Geoserver execute them in a certain sequence?
It's a little bit of both. There is a number of processes that are available by default in Geoserver. I give an example. There is an aggregate process and there is a distinct process. For example, the distinct can basically tell you the distinct values for an attribute on a spatial dataset. There are processes for computing statistics or rasters like zona statistics. There are processing for doing contouring. There are processes for doing heat maps and so on. So these are pre-built in Geoserver and freely available. There is also support for scripting in Groovy, if I remember correctly, which is a scripting languages built for the Java virtual machine for Java, which is pretty popular. It's called GeoScript, this functionality, so you can create processes quickly and deploy them in Geoserver. You can also write more compelling processes, more advanced processes in Java and deploy them in Geoserver. There is ways also to call processes from the command line, but it's not what we use most part of the time. The real power of the WPS implementation in Geoserver is the fact that you can write processes that can work in close cooperation with the other services. For example, we have this concept of rendering transformation. If there are already a few available by default, but the example is that you can code a process in a way that it can be plugged as part of the rendering process in Geoserver. Like you can make a get map request, and for example, you can have a process that contours your data on the fly. Let's say you publish a digital elevation model in Geoserver. You can ask Geoserver to basically, as part of the rendering of the dam, transform the dam from raster into vector and render lines, the contour lines at the end, rather the original raster data. So the real power in Geoserver is to manipulate data quickly that are published in Geoserver, and if possible, also as part of the other services like WMS.
Wow, that's really cool. That's really cool. So every time in that situation, when I made that get map request, I would also get, so I would get the map, obviously, the image of the data that I was interested in, and I would get the geometry.
Yep. For WMS, as long as you do the get feature info, you will get information about the underlying geometry as it's being created by the contour process. So the process is called every time as part of the rendering process itself.
I hear more and more people talking about vector tiles. Is this something that I can serve up in Geoserver?
Yes, there is actually a free and open source extension for Geoserver available as part of the downloads, which is quite well supported, and I can serve vector tiles via WMTS, but also via WMS. So it's a little bit more than just vector tiles. Lately, we have worked on adding support also for tile JSON, to make appear clients like, let's say, the usual vector tiles client that are not meant to be working with OGC services, and they expect the tile JSON specification to be implemented. So we added it to Geoserver. So for example, you can style vector tiles from Geoserver using Maputnik, which is one of the most widely known visual styler for vector tiles.
When you say extensions, are you talking about chunks of code that I download from somewhere and put in a file so GeoServer understands that it now has that functionality? Or is there something else going on here?
Yes, as I said at the beginning, Geoserver, the Geoserver product that you download, it's actually a standard composition of these extensions, the minimum set of extensions we think people need to run Geoserver. Then there is more. There is two levels of extension, the official extensions and the community extensions. This is both, let's say, a community decision as well as a maintainability decision. We try to lower the bar for contributing to Geoserver by introducing this concept of community extensions. Let's say you develop a new functionality, you think it's good for the public, you can publish it as a community extension. We don't ask too much in terms of quality, support, and everything. It's just something that you can say, I want people to get familiar with this and see if it's of interest. Official extension, well, it's a little bit more complicated. You need to have strict quality thresholds for your code. You need to be responsive on the mailing list. You are going to be part of the full build of Geoserver and testing. So if there is a failure, you need to fix it right away. Otherwise, we kick it out of the build and so on. The next step is becoming part of the core Geoserver, the core product. But this is a process that moves slowly because we don't want everything that is contributed to become part of the core. We don't want Geoserver to become 1 terabyte to download at this time. If you do too many things at the same time, it's hard to do any of them very good. That's our goal.
That makes a lot of sense. I think another thing that we haven't talked about yet, which is really important, is that the administration module of GeoServer. Could you talk a little bit about that? What can we do in there?
But Geoserver can be administered via the GUI as well as via a REST interface, which is a programmatic interface, simply put. In the smallest scenarios, in the smallest use case and deployments, there might be a single Geoserver installations where someone does things infrequently by hand, so you can go via the GUI. But we have large installations where we have tens and tens or dozens of Geoserver instances running in parallel in the cloud, also auto-scaling up and down depending on the load. In these cases, usually you can simply go there and make changes to the configuration by hand. Well, sometimes you might have seen the various memes on the web. When there is an issue, you might have to do that. But on average, that's not the way you want to work. There is usually very well-defined procedures and guidelines for making changes. There is development environment, test environment, QA, production, and things have to move between environments in an automated way. Okay, so the only way to do that is to have a REST interface. Geoserver allows you basically via this REST interface to programmatically administer it. You can do 99% of the tasks that you're needing. Only a few things can be done solely via the web interface. And I would say that this is how we do things most part of the time in our installations, where Geoserver is serving data that is continuously ingested via the REST interface without human intervention.
Wow, so we can do a lot of stuff with GeoServer, and I think you've done a great job of sort of walking us through how we get data in there, the different data formats we can make use of, the way we can distribute this data through web services, some of the magic involved with web processing services, for example. We've got this administration side of it. Is there any situation where we want to distribute data on the interweb and GeoServer is not the answer? When shouldn't we be using this?
Well, that's a good question. And I mean, as a sales guy, I should say you can always use Geoserver, but my background is as an engineer. So this is a question that talk to my engineering part. I've actually been talking to clients in the past about way to use Geoserver and not to use Geoserver. I remember this discussion with a client in precision farming, and they were actually, because someone installed Geoserver and he made a mess, okay? As it usually happens. So they call us in, we need to fix things quickly. I looked at what they did and I said, look, they are using Geoserver for some things you shouldn't, and for other things, it's the only way you want to do it. I'll give you a quick example. They were using Geoserver to make a very simple query on a point that wasn't actually moving with some attributes. So I said, this is not really why you want to have a cluster of Geoserver. Spin up a quick API and do it like that. On the other side, they were using, this was precision farming, so they were publishing a lot of raster data, and they were visualizing this raster data and allowing users to change the style on the web, basically the color map, very quickly, plus some other advanced stuff on the raster data. And they said, is it worth if we remove Geoserver and implement this ourselves? I mean, apart from the fact that all the same thing, as a sales manager, I wouldn't be wise to tell you should remove Geoserver entirely. No, otherwise I won't invoice anything. But that said, good luck with re-implementing all the raster chain from zero in a month or so. You will never get there. So I mean, generally speaking, Geoserver can be banned to do almost everything related to geospatial, but sometimes the easiest things can be done outside it. Although there are, as I said, a large number of things that are implemented in Geoserver over the years that are very robust and they are quite performant. So that I think it's a good example.
Yeah, I think so too. Hey, I forgot to ask before, but does GeoServer support time series data?
Well, I would say that the largest installations that we have use Geoserver with time series data. I can give you like a few quick examples. For example, the Luxembourg collaborative ground segment. It's actually a project from the Luxembourg Space Agency. And Geoserver is serving around 25 petabytes of Sentinel-1 and Sentinel-2 data with obviously the time dimension, so you can move back and forth in time. And we have a number of clients doing the same thing. For example, we do work a lot with ship position data and moving objects in general, where the time dimension is actually an important part of it. We do work a lot with sensor data. So in this case, it's pure time series in the sense of, you have a position that, and at this position, you have records of over records over records that are generated over time. GeoServer supports the time dimension with WMS very well, with also a few extensions to the WMS, and it does the same for WCS, for the web coverage service.
That's great. Thanks very much for that. I appreciate it. So GeoServer has been around for a while, and I'm assuming it's under active development now. What can we expect to see in GeoServer in the next versions?
Well, like all open source products, the new things are, let's say, mandated a little bit by what the clients ask. Okay, so it's always difficult to promise that something will be there. I can tell you what's interesting for us. So it might ring a bell for someone, and it might even be a good idea, a good point for getting more funding. There is a lot of work, obviously, to be, let's say, more cloud friendly. GeoServer is not cloud native, obviously, because I mean, it was born before the cloud even exists. I always get this question if GeoServer is cloud ready or is cloud available, whatever you want to call it. And I mean, you can answer yes and no at the same time, depends on who you're talking to. For us, it is because, I mean, especially with Docker and Kubernetes, we have large installations of GeoServer that spin up and down your instances dynamically without any issues. But this is, let's say, a never-ending goal to make GeoServer more and more friendly for the cloud. Even because, okay, people say cloud, but cloud for me, I always get a little bit, let's say, angry at this cloud, these jargon things from the IT. The cloud is a little bit debatable. First of all, I mean, when you say cloud, I'm talking about public clouds, and there are subtle differences between all of them: Azure, Google Cloud, AWS. Then people start to mix this with private cloud, so you see the amount of things you can talk about when you use the term cloud. It's huge, so it's an heterogeneous things. But I mean, this is something we are working more and more, although it's doable already today without doing any fancy stuff. Problem I see is that usually people put the technology ahead of the problem. So instead of understanding the problem, they start throwing technologies at it and they make it worse. Another thing that we are working on, although again, this is a little bit of an internal experiment, it's more support for 3D stuff. Let's say the key point here is the 3D tile specification. We are interested in implementing that client side, but we are looking also at ways to be able to serve data according to the specification also server side. This is very prototypal state, and it's going on entirely in our time. COG is already supported, but we want to extend support to as many cloud platforms as possible. Going back to what I said before, right now COG is supported by S3 as well as on pure HTTP, but we are working with the Google Cloud and soon, I believe, also with Azure in order to streamline the support. Another thing that we have been talking about with our clients, it's probably becoming, although many people will not be happy to hear, is more Esri friendly in terms of being able to serve our data to, for example, ArcGIS Online and ArcGIS Desktop, all the various desktop version of the Esri stuff. Because I mean, although we are all for open source, we can simply say no to people using Esri that wants to be able to connect to Geoserver, because if you work for an organization, especially public organization that are serving data to the public, they need to be able to work nicely also with Esri stuff. There is also some work going on internally in some discussion in order to, on a side, improve vector tiles generation as well as more advanced type of visualization, making use more of the database. This is the last thing I want to talk about. Geoserver tends to abstract away from the underlying database, although being it PostgreSQL or being it Oracle, although we tend to have optimized SQL for each of them, obviously. There are things that still, in our opinion, could be optimized at the cost of writing more database specific code. Like, for example, we can get advantage of the fact that now you can generate vector tiles directly in PostGIS. So when we recognize you're working with PostGIS, we can generate the vector tiles directly into it rather than outside it. So this will be probably a little bit more work to make specific database code, but it's worth it. The same thing for advanced visualization like heat maps, hexagon clustering, and things like that. If we move this to the specific database, it will be obviously faster and more scalable. Because in the end, I mean, people tend to compare what you do with software like Carto or, in the past was Google Maps and so on. We need to, on a side, be able to be independent of the various database, but at the same time, we need to make sure we exploit them as much as possible. So, I mean, if you had to look at Carto, Carto is made, at least it was made in the past for PostgreSQL, so it was using advanced PostgreSQL functionalities. We're not trying to do the same, but we need to go a little bit more in that direction.
Just on that last point you made, that's really interesting that you look around in the industry and see what people are doing and say, well, how can we keep up with them, kind of thing. Is it inspiring when this kind of thing happens, when you see movement in the industry, or is it stressful?
It's both of them. I mean, it always depends on your position, you know. As a director of a company, as a founder, it's also stressful because you need to keep up and always innovate. But at the same time, you need to make sure that things you do work well in production. You know what I mean? So it's both ways. From the technical standpoint, it's actually very interesting and it's challenging. So it's good to be probably in this market, in this field at this moment. Because, for example, with the COVID, now everybody knows what the dashboard is. I don't need to explain any longer. In the past, I was saying we do something similar. When someone was asking me, what do you do, what your company does? I was saying we do something similar by Google Maps on a smaller scale, probably more flexible, because you need on a smaller scale doesn't sound well. But if you say more flexible, yeah, it sounds not that bad. And what I say is, did you see those dashboards? Yeah, that's what we do, but it's more for the technical people rather than for the public.
That's a really good way of explaining it. I'll have to remember that. So I just want to make it clear to people that if they're interested in Geoserver, where can they go to download it and try it out for themselves?
Well, it's geoserver.org. It's very simple.
And where can I go if I want to reach out to you, if I want to reach out to GeoSolutions?
It's geosolutionsgroup.com.
Thank you very much, Simone. I've really enjoyed the conversation. Thanks for patiently walking me through what Geoserver is, what it can do, what it perhaps shouldn't be used for, and some of the functionality we can look forward to in the future. Really appreciate your time.
You're welcome.
So thanks again to OSGeo for helping make this podcast episode possible. I really appreciate your support. If you're wanting to learn more about some of the other awesome projects that OSGeo support, go along to osgeo.org and you'll see a bunch of pretty amazing open source software there that you might not already be familiar with. It's worth checking out. In terms of Geoserver itself, if you want to download it and play around with it yourself, just go to geoserver.org. Again, I'll put a link to this in the show notes so it's a little bit easier to find. And it'll just work. You'll download it for whatever environment that you're working on, and it's a pretty amazing and extremely powerful piece of software that if you're not already familiar with, it's worth checking out. If you're looking to create an enterprise solution based on Geoserver, have a look at geosolutionsgroup.com. Again, this is the company that Simone is the founder and director of, and they might be able to help you out. If that's something you're interested in, I'll put a link to them in the show notes as well. So a couple of times during this interview, we mentioned a cloud-optimized GeoTIFF. So if you're not already familiar with this, it's sometimes referred to as a COG, and it's a pretty amazing concept. So you can already produce these. If you're using, I guess, pretty much every open source piece of software that runs on GDAL will be able to output a cloud-optimized GeoTIFF. I'm pretty confident that you can also do this in an Esri environment as well. And yeah, I think this is going to be a game changer, and I think it's worth finding out more about it if you're not familiar with it already. I'll put a link to where you can find out more about cloud-optimized GeoTIFFs in the show notes. And again, I think this is something really interesting. It's going to change the way we share raster data on the internet. It's worth checking out. And that's it for another episode of the Mapscaping podcast. Thank you so much for tuning in again this week. It's much appreciated. As always, you're more than welcome to reach out to me. You can find me on Twitter at Mapscaping, or search for Daniel Mapscaping, something like that, on LinkedIn. And yeah, I'm pretty sure that I'll show up there. Otherwise, you're more than welcome to reach out to me on info@mapscaping.com. If email is your thing, I would love to hear from you. I'll be back again next week with another episode. I hope that you'll take the time to listen then, and we'll talk soon. Bye.